On a Tuesday afternoon in 1945, physicist Louis Slotin stood over a small metal sphere, performing an experiment he had done dozens of times before. His screwdriver slipped. There was no loud crash, nothing visibly changed in the room, and he felt no pain. Yet, less than a second later, Slotin knew he was going to die. He had roughly 9 days left. How does a completely routine, well-practiced scientific procedure silently transform into an inescapable, lethal countdown? This was a grapefruit-sized sphere of plutonium, forged at the height of the Manhattan Project. The goal of the experiment was to test criticality. By bringing reflectors closer to the core, researchers pushed the material right to the edge of a nuclear chain reaction. Push it slightly too far, and the material releases a lethal burst of radiation. The scientists working with it called it the demon core. It had already killed one physicist, Harry Daghlian, in 1945, when a single tungsten carbide brick was accidentally dropped onto the assembly. Despite that fatal accident, less than a year later, the exact same core was back on a lab bench, with Louis Slotin running the tests. Harry Daghlian was dead, yet the core remained on the bench, its lethality proven, but the protocol for handling it still relied on the steady hands of a single person. Slotin's specific testing method involved manually lowering a beryllium shell, a metal casing designed to reflect subatomic particles back inward over the plutonium core to edge it toward criticality. To keep the two halves from closing entirely, he relied on a single spacer, the blade of a standard flathead screwdriver. On May 21, 1946, Slotin was performing this maneuver freehand, with 7 other colleagues observing in the room. But then, completely without warning, the flathead blade slipped. The heavy beryllium shell instantly snapped completely shut. What absolute, irreversible physical reactions are triggered in the total darkness of that closed metal shell? In a fraction of a second, the core went supercritical. Massive bursts of radiation instantly tore through the surrounding air and human tissue. The room flooded with a blinding blue glow. This was Cherenkov radiation, the visible signature of particles traveling faster than light through the surrounding medium. Slotin felt an immediate wave of heat wash over him, followed by a sharp, sour metallic taste in his mouth. He didn't run. In one continuous motion, he ripped the heavy shell apart with his bare hands to stop the reaction. He saved the 7 other men in the room. But by pulling those halves apart, he absorbed a lethal dose of radiation in under 1 second. With the reaction stopped, but a fatal dose of energy already absorbed, what exactly is this level of radiation about to do to his cellular structure? Slotin remained completely lucid following the flash. He calmly instructed colleagues to mark exactly where they'd been standing. This floor plan shows why. Their distances provided crucial data to calculate precise radiation exposure and survival odds of everyone behind him. Over the next 9 days, doctors watched a biological collapse they had almost no prior data on. His white blood cell count plummeted. Third-degree burns formed on his skin, mapping perfectly to the angles where the radiation had pierced his body. He remained consciously aware as his digestive system began shutting down, experiencing the internal biological collapse of acute radiation syndrome from the inside out. Sometimes the most revealing part of a fatal experiment is what a person chooses to do once they already know the outcome. Following the accident, hands-on criticality testing was banned completely. The process was entirely replaced by remote-controlled mechanical systems. The demon core was scheduled for a nuclear test later that same year, melted down and permanently absorbed into the U.S. nuclear stockpile. The demon core leaves behind a question that physics cannot answer. When all safety nets vanish and a person knows exactly when they will die, what do they do with the time that remains?